note about the Q&A before we begin. This year, everyone in JNUC can participate in the Q&A via the JNUC app. So please take a moment to open the app and simply choose session Q&A in the app. Locate the session from the list and start submitting and upvoting questions. Our virtual attendees will join in as well, asking questions directly from the session page, and your submitted questions will fuel the Q&A segment of this session. So thank you for your attention. And now let me welcome on the stage Tony Williams and defensive driving for the shell.
Thank you. I've got to say, I like having that light there so I can only see the first 3 rows. The rest of you will scare me. My name is Tony Williams and I work for the Commonwealth Bank of Australia. I'm part of the Macintosh team there. I'd like to start by acknowledging the Kawawitikan people, the original custodians of this land, and I'd pay my respects to their elders, past and present. And I also extend that respect to any other Indigenous peoples here with us today. Well, that's some impressive crashing there. Though I think our young lady in the middle has got in a loop. We need some defensive driving. The Queensland government of Australia said the defensive driving course should have those 4 things: hazard perception, risk avoidance, reducing overconfidence, and situational awareness. So we're going to talk about those as part of defensive programming. Defensive programming is intended to develop programs that can detect potential problems and make a predetermined response. It makes sure software works even under unforeseen circumstances. It's often used for secure software, but we can take some of the advantages of defensive driving and use it in our shell programming. To start, accept you have bad habits. I've been doing this for decades and my code looks terrible sometimes because I have awful programming habits. Be humble. This is the reducing overconfidence. You won't write perfect code from the start. Secondly, make code comprehensible. It should be easy to understand by both you and your peers. And in fact, you'll find that if you make your code comprehensible, it's better when 3 years down the track, Apple changed something in the operating system and your code fails. Make code predictable. As part of its comprehensibility, make sure that people understand what the code should do at various points. This is really hazard perception, and in resilient programming they call it handling errors gracefully. Put together, if we are writing code that is comprehensible and predictable, we're writing code to a quality standard, and it's good to keep that high. Dead programs never lie. You see this in some articles and books. What does it mean? A dead program does less damage than a broken one. So you should be checking for problems as early as possible and immediately exiting, because code that is half broken may well do damage to the operating system. This one I read from between the lines. It comes under the heading of situational awareness. We need to know well both the system in which our code runs, like the network and other infrastructure, and the command line software we use, such as sed, grep, and awk. Can I have a quick show of hands? Who feels comfortable using sed, awk, and grep? Okay, about a quarter. Okay, because I'm spending a lot of time on explaining some of those. So it's good to know. Taking all those things into consideration, how does that look when we apply it to some real code? What about an example? Okay, that's terrible, that's awful, that's a disaster. I assure you that code does actually work. It's hard to know where to start applying our new rules. So we start at the top. That's a better start. Now I'm writing with a little quality. I'm putting an informative header on the script, and I'm telling you who to blame for it. Hopefully it's better code before I ship. To explain those lines a little, when you run a script from an MDM, such as Jamf Pro, the system will often think that the user and the user ID is not actually the person sitting in front. They'll think it's your root or some Jamf admin user. So we need to discover who the user is and their user ID, which is a number just above 500. Further down, I've added some comments, including a long one to explain what that complicated line is up to. That's a pipe. The output from one tool becomes the input for the next one along the pipe. Here we have 4 commands in the pipe. I also gave the variables an understandable name. This code is looking more comprehensible. Here I add a line that tells the world what the script is up to. This is the simplest way of reporting what's happening. Not only does it make the code more easily understood, it also makes the script more predictable. And how about we spend a few minutes looking at other ways of getting the script to phone home? If we just run the script, the output will be to the console. It will be in our terminal. We can, if we like, redirect that output to a file. And that's what we're doing on the second line. The 2 greater than signs mean that the output will be added to the end of the log file rather than a single greater than makes a new file every time. Then, the problem with that, of course, is that we don't see anything on the screen. We can instead use a pipe and pipe it to a piece of software called T, which prints to both the console and to a file. There are 2 different output streams of a piece of shell programming. There's standard out, which is stream number 1, and there's standard error, which is stream number 2. This is a function you can include in your scripts to make writing to standard error easier. The $@ symbol means that both output 1 and output 2 are being redirected to standard error. Let's have a look at it in action. When we run it, you can see that it says this is standard out, this is standard error. If we redirect stream 1, we'll see that all we get is a standard error. If we redirect stream 2, all we see is standard out. The destination of /dev/null is actually just a way of throwing it away. I've taken out a number of blank lines to fit this on a screen. Just as we can have a function to echo to standard error, we can have one that echoes to our log. When we are writing the log, it might be useful to print the date. So what we've got there is a date command that prints out the date. The +%f means that it will print in ISO 8601 order, year, month, day. And the %t will print out the time, hours, minutes, and seconds. So we call this function to write to both the log and output. You can see the similarities, but we add the extra line to echo to out. Let's get back to our script. Here is the line that finds the user's Active Directory home folder. It's entirely possible that it can fail. We'll have a little bit of a talk about exactly what it does. The dollar and the opening brace, and all the way to the end of the line, you can see the matching brace. That means the output of that command is stored in the variable AD home. Now, app SSO, which is at the start of that, can be easily upset. If you don't have a Kerberos ticket, then that won't work. So immediately, that will cause problems. So let's build to accommodate that error. Here we test the variable and tell the console what happened and exit if it's blank. That's what -z means. It means, is this variable blank? If it was -v, it would check if it had been set at all. But it is actually set, it's just set wrongly if there's a problem with that SSO. And when we run it, you can see that it says no AD directory found, and that echo statement echoes the result of the last command, which you can see is 1, which is a fail. So that's false. In shell programming, 0 is true, and false is actually not true. So it's any other value apart from 0. Most people use 1. If you have multiple error types, you can use multiple numbers. Let's look at that command again. Notice how the two sed commands look complex. The second one suffers from what is called the picket fence problem. It's like a broken picket fence with slashes going all over the place. You can probably guess from the comment that the second is reversing the slashes in the AD home directory to go from Windows to Mac. Now, almost every sed tutorial says that this is how you write a sed command, with splashes between each piece of the command. Sed is a stream editor, which means it takes the text, it runs the command that you've asked, and then outputs the text. We have s/what we're finding, what we want to find, slash and then replace, and then slash with some options. Now, that's not actually true. Where are we? There we go. Come on. Okay, I've got a slide missing. Oh, there it is. Sorry. You can actually use any command you like, any character you like. I use octothorpes, the hash character, and I use it. One of the reasons I use it is so that I can tell people that it's called an octothorpe. And the advantage of that, if you have a look at the last sed command, is it becomes much easier to understand what it's doing because it doesn't have those braces going over every which way. I routinely use the octothorpe because routinely we're having to deal with things like paths in shell programming. Then you'll also notice that we're running sed twice. And we can actually do something about that. We can, if we like, run two commands with one sed and put a return between them. That will actually work. It looks awful, but it does work. Instead, we can put a semicolon between the two commands. But in fact, it's better if we use a -e, which I assume is short for execute, before each of the two commands. Now let me spend a few minutes talking about sed and about what we see in front of us. Sed is short for stream editor, and it was developed very early in the days of Unix to run the same commands as the commanders did as ed, but to do it on a stream of text. Now what we have here is two substitutions. The first one is looking for the XML around the AD home variable. And the parentheses mean that this portion of the string is something which I want to refer to later on. Then the /1 refers back to that. So it, in fact, extracts the AD home directory from the string. And then the second one is taking / and replacing it with /. The G means to do it every time you see a /, not just the first time. Now to talk about debugging. What to do when we've lost control and we're heading straight for the cliff. We can see Brian Kernighan's view back in 1979, and to be honest, nothing much has changed. For debugging shells, you find yourself using print statements quite a lot. So here we have a section of our script, and you can see that we're echoing out the value of each variable as we define it. And then it's used at the bottom to do our command. Here you can see the UID. Launch control is very useful in that it allows you to run a command as if you are a particular user. In this case, it's the user behind the keyboard. Perhaps we can find a better way of reporting the status. We'll do a slight modification of the redirect script. Now the shebang line up the top. That top first line is called a shebang, and it says this script will be run by the command found at /bin/zsh. Now that is literally the string that will be used, the shell that will be used. That means we can actually pass arguments to that shell. And here we're using -o xtrace. That means set the option xtrace. ZSH has a number of options on how to control how it behaves. Xtrace is the one we're setting here. An xtrace has ZSH printing each line as it executes. So here we see redirect to, and we're running, the second line then says, yes, we're running a command, echo this to standard out. We then see the result of the command, and we see the same thing at line 13. And after that, you see it's jumped into the function, which we defined, and it's saying that standard, line 2 of that function is echoed as a standard error, and we then see the result. And finally, we jump back out of the function, and we see the output of line 16. Here we are, but this time we're setting the option inside the script rather than using the shebang line. That means that we can turn it on and off at will if we want to. You can also see that with echo standard error, I've moved the curly brace up one line. And the result of that is that the line number in the echo standard error output is correct. You see that down there, line 13, echo standard error, this is standard error. Now after that, the first line of the function. Longer scripts can have a great deal of output with xtrace. How do we fix that? You can see now that what we're doing is we're setting an option inside the function. That means it will only run inside the function. Once the function exits, it will be turned off. Here we see that's exactly what happens. We only see the line that's executed within the function. Because of the set-op line, we once again have 2 as the line number. Sometimes it's not convenient to put code in a function. Here I use set-op to turn on trace and unset opt, which turns it off. So I only get a small section of the script traced. And here we see it. Here we go back to the shebang line, and here we see -e, -u, -o, and pipe fail. So what does that all mean? -u means using an unset variable is an error. So if we had put dial logged in user as the first line of the script before it was set, that would be considered failing. -e tells the shell to exit if a command exits with an error. This is dying. This is to make sure that we die early. And pipe fail will cause an error if part of the pipe has an error. So for example, if scutil didn't give us the right output and instead printed out an error, then that pipe would fail. Just to confuse you, in ZSH, pipe fail has an underscore between two words, and in Bash it doesn't. Who knows? Now back to some more rules in writing defensive code and systems. I won't go into as much depth as that last section, so it's summed up more as maxims. To start, understand the problem and don't lose focus on it. The mount script you have seen so much of wasn't written for fun. It was the answer to providing Kerberos single sign extension, a way for users to quickly open their AD home folder. If you're familiar with Nomad, Nomad has a menu item, open your home folder. And so when we moved from Nomad to Kerberos single sign-on, we had to give people a way to do exactly the same thing. It doesn't need to do more, it just has to do that one task. Test properly. It's important to test as much as you can. For mount.sh, I tested it on a Mac where I thought it would work, a Mac that didn't have the Kerberos extension installed, and one that had the extension but wasn't signed into Kerberos. That seemed to me all the three possible variations I could have, so I tested it on all three. Constantly improve. You need to keep on top of code. The system might be shifting under you, or there may be a better way. Always look at improving. Just a second, I have an example. Remember the code from the top of mount.zsh? Mount.zsh doesn't really need to know the user's name, it just needs to know the user ID. And I figured out a way of finding that out that was better. If I just run the scutil command, though it is almost at the bottom, down there, no, there it is, user ID, and even better down there is UID 501. So those two lines can become one, and that's what you see in the new code to the right. It just runs scutil once and gets the logged in user ID. Now, I guess I should have explained a bit about what awk does. Awk looks for the text between the two slashes, and on any line that matches, it runs the command between the curly braces. In this case, print number 3 means print the third field across the line. Make names meaningful. Nobody is actually taxing you on the length of your variable names. There's no cost. So make sure that they're long enough to tell people what they're for. Once again, here's the bottom of the mount script. The name of each variable tells you what it holds. They could have been perhaps longer, but they're good enough the way they are. The one that I wondered about was whether FQDN should actually say fully qualified domain name, but I think most people understand what FQDN means these days. And you also see that the comments explain exactly what's happening, and those comments bring me to the next rule. Always document. This means not only writing a document that tells people how and why to run your script, it also means using comments to document the code itself. A rule of thumb I heard many years ago was that you should write comments inside your scripts as if the next person who reads your code is a homicidal maniac who knows your home address. The truth is, you may have trouble yourself. You know, sometimes you will not look at a script for 4 or 5 years until, Apple in all their glory decide to change something and your script will break. You then need to understand it well. So always document. Those two about names and documenting are, once again, they're the key to comprehensible code. For the last one, use version control. It will save you more than once. Learn the basics of using Git. The basics are actually quite simple. You can use Git for very complicated things, but if you just want it for version control, it's fairly simple to understand. So create a Git repository and use Git. You don't need a repo for perhaps every small script. You might have one repo for all your scripts. For larger, more complex code, put them into their own GitHub repo. Here are some resources that I thought you should have. There are 3 books: The Awk Programming Language by Aho, Kernighan and Weinberger, the 3 authors of Awk. Awk actually stands for Aho, Weinberger and Kerrigan. And then there's a very good O'Reilly book called Said and Awk by Doherty and Robbins. And there is a superb book on regular expressions. It really is absolutely fantastic, by Jeffrey Friedel, Mastering Regular Expressions. And then you can see there are some links there to some useful places. This presentation is not quite public. I was waiting until after I did this presentation to make it public, but it will be public this evening. Before I open the floor to questions, I'd like to give Jamf Heroes a plug. Jamf Heroes is the community engagement system at Jamf. It gives you access to a whole bunch of news about what is happening at Jamf and gives you a number of tasks for which you can earn points and use those points to buy some really cool swag. They've done some great t-shirts, some good coffee mugs. Visit them in the expo. They're part of the Jamf booth, and have a talk to them, and you may well decide to apply. I'll open the floor to questions.
Okay. We have a number of questions in the app. So, first of all, the most voted question is actually a recognition. So, anonymous user posted, "Thank you for introducing me to the word octothorpe."
Yeah, I know. I love being a pedant, I really do. So when somebody says hash, I can always say, no, that's octothorpe. I recommend it to you. You should all do it.
Okay, second one, the second most voted is again a recognition. Huge respect from Kyla Levins. First session I've been in that has done a land acknowledgement.
Thank you.
Right after, anonymous question, is there a particular place or tool you used to learn Z shell to this level?
Look, nowadays, back when I did it, I used a book called The Unix Programming Environment by Kernighan and Pike. And O'Reilly have a good shell programming book for Bash. But these days, the best way to learn is to have a task and start Googling. Really? Or ask on the Mac admin Slack channel, and somebody might have something that almost does what you want, so you end up only having to modify somebody else's code. That's the way you learn. You just need a task, and then from that point on. It's the best way to learn any language. That's the way I learned Python.
Okay. Next one. Given the variety of string manipulation commands here, how do you decide on which tool is most appropriate for individual use cases? Okay,
let's start with grep. Grep is actually named after a command in ed, which was the first editor ever on Unix. And it's short for G/, then a regular expression, then /p. And what that did in ed was it printed all the lines that matched that expression. And that's exactly what grep does. Grep allows you to to find the one line that you would then want to manipulate with other tools. Sed is very good for find and replace. Awk, if you find yourself using grep twice, awk is good, because awk allows you to search for 2 different strings. And also it's very good at manipulating the text to extract the one small piece you want. So that's where you use awk.
Okay, next one. Why no mention of set -x?
I just don't use it.
Okay, thank you. Next one. Do you have any resources from switching from Bash to Z shell? So resources for switching from Bash to Z shell.
All the scripts you saw run on Z shell. I used to call it ZSH, but I looked at the documentation. We should pronounce it Z shell. So of course, Z sells Z shells by the Z shore. And in fact, apart from the pipe fail, all of that will also run on Bash. They're very, very close to each other. Also notice that I always call my Z shell scripts .zsh, so that I can always look through a list and say, okay, these are the ones that might cause me problems down the track when Apple in all their glory decide to do with Bash the same thing they do with Python and just rip it out. They're threatening that, they've been threatening it for years. So I need to be able to very quickly say, okay, here are the ones that I need to check. I wish there was a tool that did check. The more complicated your code, the more likely it is that something will break. Arrays is generally where Bash code will break in ZSH. Bash will allow you to break a string on the words, and ZSH will treat that as all one blob. That's generally the most obvious places where you'll break code.
Okay. Next one, another recognition. The books, that's my go-to library. From Miles Weissman.
Okay, could I have that again? What did you say?
Here we go. The books that were in your presentation.
Yeah. Well, the first thing I'd say about books is I love learning from books. And Brian Kernighan has written a whole bunch of books, and every single one of them is worth the money. The other thing I would say is that the O'Reilly publishing house published some really good books. So I don't know if they do a Z shell one, but they certainly do a good Bash one. The documentation at zsh.org is pretty good. And it'll generally sort out most of your questions.
Right. Next one. Do you use shell check? If so, do you have any recommendation of a similar tool for Z shell?
Okay, that's the big question in Z shell programming, is shell check will mark as wrong some Z shell code, and there is no equivalent. So I currently have Visual Studio Code, which is the editor I recommend to everybody, running shell check even on my Z shell code, because I look at it and I think, oh, no, that's right. But that's taken some experience to discover where those problems are. So if you want to turn off shell check inside Visual Studio Code for .zsh files, I would understand. I wish there was one that worked for Z shell. It is the big burning problem.
Right. So in the Q&A there is a link to a book, Bash to Z shell. So if you are interested, check it out. And next question. Any best practice recommendations for writing to logs and maybe restricting log file sizes?
Okay. If you're running Bash shells in policies, then don't write to a log file, just write to output, because that will appear in the policy log. If you're writing large extension attributes, then you may want to log out to a file, but what you do is at the top of each run of the extension attribute, you empty the file so that it doesn't blow out. And extension attributes are done at check-in, and that's usually a decent delay between check-in so you can find out what's going on. The other thing is that dates and times are very good to have in the log. And you might want to, in fact, with a long script, start by outputting a line that says, here I'm starting at this time, and then go on.
Okay, thank you. And the last question that is here, for the app-sso command, will that work when running as admin/root?
It will work. If you run it in the terminal, it requires sudo. It's only useful if you're running Kerberos single sign-on. If you're not running Kerberos, then app-sso will not return the right results.
Okay, thank you very much. There are no questions left in the online Q&A, so I will give you the chance to put a question here in the room.
Raise your hand if you want. No, okay. You know where to find me.
So thank you very much for your attention, and give some applause to Tony.
Thank you very much. Thank you very much.
Thank you.
I truly appreciate a good audience. Thank you very much.